All right, good evening, ladies and gentlemen. Today I will be doing a quick review of some of the radical rules. This will be more specifically simplifying radicals and then also how to handle multiplication and division. Now, quite frequently people build up simplifying radicals to be this very, very complicated idea and say, oh, it's not like anything else, but really simplifying radicals is just like any other math. If I asked you, if I said 5 plus 4 and I asked you to simplify, you would bring it together and say it's 9, okay? Well, if you have the square root of 4, to make that a little bit simpler, we could say that's 2, okay? Anytime we do perfect squares, we can make that into a whole number. And if you can make it into a whole number, why not, right? Or if you are given the fraction 4 divided by 2, why not simplify that and make it just a simple 2? Things like that. It's always better to simplify it if you can. So when you look at this first example, you have the square root of 125n. First of all, you do really should be fairly familiar with your square roots. For my classes, I quite often give them at least or not square roots, but perfect squares. I quite often give them the perfect squares. So always check to see if that perfect square is up on the board. If it is not up on the board, I would still recommend that you check it because, for example, I believe it was someone had the square root of 400 as one of their problems. And they were like, oh, I don't really know. Now, you could break this down into smaller perfect squares and say, oh, well, you can make that the square root of 4 and the square root of 100. That gives me 2 and 10 to get 20. Or you at least type it into your calculator. A reminder, your calculators do square roots. So always check it on your calculator first. Type in the square root of, for example, 216. See if it comes out to be a whole number. If it does, awesome. It saves you a lot of time. You can just make it a perfect number. If it comes out as a decimal, that's when you're going to want to go about simplifying it however you wish. Now, there's two different ways that I've shown simplifying to my classes. The first way is to break it up into two pieces, in which case one of them should be a perfect square, like 25, and the other does not have to be a perfect square. Now, the only caution I offer here is sometimes people pick a number, like let's say with 216, you pick 4. And you say, I'm going to break it down into a 4 and a 54. Well, that's all great and dandy, but 54 could keep being broken down into other perfect squares. So I would say, if you're really comfortable picking out the biggest possible perfect square, then great. If not, go with the second option I'm going to show you in a second. So this first one, if we continue with this method, I've broken it up into two numbers. I've broken it up into the square root of 25 and the square root of 5. If you're wondering what's happening with the end, I personally always deal with the whole numbers first, and then I deal with the variables last, because they're kind of done a little differently. So the square root of 25, if you know your list of perfect squares, should work out to be a 5. Okay, I remind you that it has changed. It is no longer a 25, it is now a 5, which is why it got to move out of the house. The square root of 5, on the other hand, should not be listed in your perfect squares. Therefore, it cannot change and has to stay in the house. So kind of keep that in mind. Quite frequently, people will get ones like, square root of 8, and they'll be like, okay, I'm going to break that down into a 4 and a 2. This works out to actually be the same as 5. But my point being is that sometimes people, should get a 3 square root of 2, but they end up switching it and putting the 3 inside. Things like that. This example would have been the square root of 18, right? You could break this up into the square root of 9 and the square root of 2, and then getting that 3 square root of 2, but quite frequently people get them backwards. So the number that changes, the 9 becomes a 3, moves on the outside of the house. The 2, on the other hand, stays in the house. Now, I mentioned earlier that there's a second method to simplifying square roots. This goes back to, for my classes, the previous unit on factor trees, which basically say you can split this up into anything your heart desires. Let's say I split this up into a 2 and a 180. Well, then the 180 could keep going. Maybe I divide it by a 4 this time, and I say 4 and 27. Well, the 4 becomes a 2 and a 2. The 27, we could keep going. We could divide that by a 3 and a 9, and then the 9 becomes a 3 and a 3. So this would be a factor tree. Now, how are factor trees helpful in this situation? If you recall, at least in my classes, when we first looked at variables, we said that if you have a k2, that's 2 k's, and in a square root, you need a pair in order for them to move out of the house. So here's your pair. We kind of described it as getting married. These two got married, got to move out of the house and become a single family, a single K. So if you can find a pair like this, then they get to move out of the house. So if I come over to my factor tree, here's a pair of 2's, here's a pair of 3's. So what can move out of the house? I can have a 2 move out of the house because there's a pair, they got married and moved out. Here's a pair of 3's, they get to move out. And then what was left inside that did not get married? Well, you had a 2 and a 3 left inside. So if you keep in mind that this is all multiplication, that means you're going to have a 6 on the outside and a 6 on the inside. And then again, of course, that V, sadly, there was only one V, so he didn't get to pair up, just like the 3 and the 2. He had no pair, has to stay in the house. All right, so these are 2 different ways you can choose to simplify. Now, simplifying is the key, and I strongly encourage you to keep practicing these types of problems, because if you do not know how to simplify, then when you start getting into stuff like multiplication and division on the next couple pages, you won't know how to take that kind of final last step. So let me kind of explain what I mean here. There are 2 basic rules when combining or bringing together square roots. The most basic foundation rule is that anything inside of a square root can be multiplied or divided, as I show you on the next page, and then anything outside of the house can be multiplied. So in this case, looking at this, the 3 is the only thing outside the house, so it's going to kind of stay outside alone. What's in the square root, however, is going to change and become 12 times 6, which gives me 72. Now this is completely done with the multiplying. Multiplication is done. This is finite. However, then it goes back to this rule of simplifying, which is what we did on the front page. So now you'd want to go back, and whichever method you chose that you liked, I would go about it that method. So maybe you would want to break this down into 9 and an 8. This would become a 3 and a 3. The 8 would keep going and become 4 and 2. The 4 would become a 2 and 2, and you kind of have everything factored out. Then you go back and you say, okay, here's a pair, here's a pair. So that means I'm going to have, don't forget about this 3 out in front. I'm just going to go ahead and rewrite them so I don't forget about them. Then I have a pair of 3's, which means I have a new 3 coming in. I have a pair of 2's, so that means I have a 2 coming in. And then this lonely 2 had nobody, so he stays in the house. Then it's just a matter of simplifying. You're going to get 18 on the outside and a 2 on the inside as your final answer. So these are really nothing new than what we did on the front, other than the fact of, do you know how to bring these together? So for example, these are both in the house, bring them together, that gives you the square root of 50. Then of course you want to simplify that just like we talked about on the front, but all these multiplication ones just dwindle down to bringing them together. So even the ones with variables, bring the 15 and the 10 together. Everything here is in the house, so make sure when you bring it together it's still in the house. And then you have 2 n's, 3 n's, that becomes n5. Same exact thing. Sometimes people have questions about number 5 because they're like, oh, there's a 4 and a negative on the outside. No problem, multiply it. What's negative 4 times a negative, 1? Well, negative times negative becomes positive, and then deal with the 15 and the 3. That's going to become 45. And then, of course, again, just as the front, deal with that 45. Don't lose track of the 4 on the outside. So like up here with the 3, I said don't lose track of him. He carries all the way through until the very end, and then you can kind of multiply everything on the outside. Same thing with this one. Sure, go ahead and deal with the 45, breaking that up, but just don't lose track of that 4 out in front. It's very, very important. So when you simplify that square root of 45, there's still that 4 out in front. Just keep that in mind. Then moving on to the back side, you have division. Again, same rules as multiplication. If they are both in the house, you can go ahead and bring them together in one house. Now the only thing with division is it's not quite as straightforward as multiplication, where you're saying 4 times 5. Quite often with division you have to reduce these fractions. So you have 15 over 5. If I reduce that, that's going to become 3 over 4. Then going about it from this point, you're like, okay, well I have a 3 over 4. What do I have to do here? I would go back to splitting it up, because if you notice, you have a square root of 4. That's really nice because the square root of 4 becomes a 2. Now some caution I offer here is we actually only dealt with the 15 and the 20. There's still the problem of that 5 out in front, and very similar to multiplication, just make sure you account for him in the end. You can just kind of leave him out there until you deal with him. He should go on the bottom, so he'll be on the bottom with the 2, making that 10. Some of the problems when it comes to division, it's actually simpler not to divide like this. So if you wanted to go ahead and put the 8 and the 100 together, that's perfectly fine. Or you could say, what's the square root of 100? That's 10, because if you recall, square root of 100 is on our list of perfect squares. Then the square root of 8 on the top. Now square root of 8, very similar to what we talked about in the front. Again, it always comes down to simplify. The square root of 8 can be split up into a 4 and a 2, making that 2 square root of 2 over 10. And then if you recall in class, we said if you can simplify the numbers on the outside, these are both on the outside, you should. The house stays the same, because remember, things outside and things inside don't mix. But things that are both on the outside, you can go ahead and simplify. And then the last thing I'll end with is rationalizing. I will say that if you're working on this worksheet at home, I would put like kind of a line between these two, because up top here you're dividing, but down here you're rationalizing. So kind of keep that in mind if you're looking at these problems. There will be a clear division most of the time in my classes. So rationalizing basically says square roots cannot be on the bottom. So if you look at all these problems, they have these square roots on the bottom. That's a problem. If it was like up top where you have, square root of 100, well, the square root of 100 kind of took care of itself. It went away. But these problems, no matter what you try, they don't really take care of themselves. So what you have to do is actually change the problem by multiplying top and bottom by something. So if you choose to multiply it by itself, that quite often gives you a pair of 5s. Here's 2 5s. And if you recall with the variables, when you have 2 of them, it gets to come out of the house. Now in the top, you still have a 4 and a square root of 5. One is outside, one is inside, so they're not going to mix. Another way that some people look at this is, yeah, sure, I'm going to multiply it by a square root of 3. But keep in mind that you are multiplying it by a square root of 3. So on the top, you will actually get a square root of 4, square root of 3 becomes 12. And on the bottom, you'll have that 5, of course, hanging out front there, but the 3 and the 3 will become a 9. If you want to look at it that way, that's perfectly fine. Just make sure that you simplify it after that point. So this one, I would say the square root of 12, actually it's more convenient to keep it as a 4 and a 3. And then on the bottom, that 9 is going to change into a 3. The square root of 9 becomes 3. Now the reason that I said it's more convenient to leave the 4 and the 3 separate is because the square root of 4 becomes 2, and the 3 just kind of stays, in the house. On the bottom, you're going to get that 15. Now check it. 2 and 5 don't really simplify, so that would be your final answer with the 2 square root of 3 over 15. So hopefully I kind of hit everything here. Again, if you're still not very comfortable with your perfect squares, make sure you review those. This is just kind of a list of them. Make sure you review those and know that anytime you find yourself at a perfect square, they're going to come out to a whole number that no longer has a house. The house goes away. With perfect squares, the house goes away. So I hope this video helped, and good luck on your quiz.